Domain and range. It's talking about the x values and the y values of a graph. So if I have a casual little graph going on, how far along horizontally my graph will go is my domain, which is my x values. We represent domain by x is an element of. That's what the little e stands for. Range is the vertical height of our graph. So it's all the values that y exists for or is an element of for the graph. So that's how we know that we're either talking about the domain or the range. When we're talking about domain and range as well, you'll either have, if you have endpoints or restrictions, you'll have an open point or a closed point. Open points, open circle, I think curve as I'm drawing it, I think, well, that is an open bracket. Coloured in dot is a closed point, it is a square bracket. We don't ever actually touch the points with an open point, we do touch the points with a closed point. Another thing to note is all real numbers. The R with a double leg is all real numbers. And that is a way to represent negative infinity to infinity. So if you have every number represented between negative infinity and infinity, that is all real numbers. Another thing to note is that as we can never touch infinity, because it's always getting bigger and bigger and bigger, it is an open bracket. So let's talk about the domain and range of these graphs. So for my linear one here, we can see that, well, x, the graph exists for x is -1, -2, -3, -4, etc., etc., etc. And it's going to keep going all the way down to negative infinity. So the smallest x value we can have is negative infinity. Then we look at the biggest x value we can have. So we've got 1, 2, 3, 4, 5, etc. all the way to positive infinity. So the biggest number we can have is infinity. So the other way we could write that is x is an element of all real numbers. Same sort of thing with our y. Smallest number, -1, -2, -3, all the way to negative infinity. And going up the same, positive infinity. So y is also an element of all real numbers. With my quadratic over here, well, x, we are going on to infinity and infinity. So no matter what x value we have, it will exist for everything. Same with going up, we'll go to positive infinity. So x is still all real values. But with y, we can see, well, the smallest number that my graph is existing for is -1. So -1 is the smallest value of y we have on this graph. But if we keep going up and up and up, we'll get to infinity. And as this graph doesn't have an endpoint, but it actually passes through that value -1, it is a closed bracket. So up here, with our other linear graph, same sort of thing. We think, okay, well, x, what is the smallest x value I have? Well, the smallest one is -3. Biggest value, +3. And it's a coloured in dot on that end at -3, so is square bracket, open dot at +3, open bracket. Y is an element of smallest y value, 2, biggest y value, 4, and we're reversing our brackets for that one because he's open at 2, closed at 4. So that's how we do domain and range when we've got a restriction. We just continue to look at what is the smallest and biggest value of each of our y and x's. So here x, well, smallest x is -2, biggest one is 1. So we can put our values in nice and easy. Then we got to think about our brackets. Open dot there, open dot there. So they're both curvy. Smallest y is -1, biggest y is 3. Open dot at 3, but we're actually physically touching the graph down here at -1, close bracket.